Hello everyone, welcome to the Distilling Insight YouTube channel. So I'm happy to tell you that we are moving into another aspect in our mathematics series. And the new aspect we are moving into today is on mensuration formula for plane shapes. So I'll be setting some backgrounds for those that will be joining us on this journey. Now, what are plane shapes? Plane shapes, they are two-dimensional shapes. They are 2D. Now, what it meant by 2D, two-dimensional, is that they don't have more than the length and the breadth. They don't have more than the length and the breadth. What we are looking at here is that we are looking at how these things are interrelated, how they are interrelated. So when we're talking about plane shapes, the mesurations that are being done under the plane shapes are perimeter and the area. When we talk about the perimeter, what we are talking about is summing all sides. So when we say perimeter, we are saying sum of all sides, and we are talking about area, we are talking about the inner space that is being covered. Well, before we dive in, what are the plane shapes that are two-dimensional? We have the rectangle. Rectangle is a two-dimensional plane shape like this that has the length and the breadth. Now, the second is a square. Now, each of these things has its properties. Now, this square, we are having all sides to be equal. Now, another one after that is the trapezium. Trapezium is drawn like this. Now, after the trapezium, we have circle. After circle, we have parallelogram. Now, after parallelogram, we have rhombus. We have rhombus. So, for the rhombus is drawn this way. Rhombus and square have things in common, that all sides are equal, and that's for the rhombus. Then after the rhombus, we can also consider a sector as a plane shape. A sector being two-dimensional. A sector. But what we are going to be elaborating more here today is talking about each of these shapes and how they arrive at their perimeter and their area. So now, the first thing that we're going to be considering now is the rectangle. So the area of rectangle, meaning the inner space here, the area equals length times breadth. The area of this rectangle, meaning the inner space in here, is length times breadth. When you now talk about the perimeter, as I've told you, perimeter of any shape is sum of all sides. So perimeter of any shape is sum of all sides. So if you want to get the perimeter of this rectangle, it means if this is the length, this is the length, this is the breadth, and this is the breadth. What you are just saying is the perimeter of a rectangle is L plus L plus B plus B, right? Then L plus L will give you 2L. Then B plus B will give you 2B. Then we're having 2L plus B. So that's how they arrive at the formula for perimeter of a rectangle. So you don't need to put the formula in your head. Just know that perimeter of a rectangle or any shape is sum of all sides. Then if you want to arrive at the formula to use before solving such question, you can just use perimeter equals to 2L plus B, and that is all. You get your answer. So we've gotten that of rectangle for the area of rectangle and perimeter of a rectangle. Now, the next thing is a square. Now, when you talk about a square, one unique property about square is that all sides are equal, meaning the length and the breadth are equal to each other. So if the length and the breadth are equal to each other, we can come into a conclusion that the same thing, all of them are the L. Now, to get the inner surface, which is the area of the square, it is now going to be L times L, and that is L square. That's the area of a square. Now, to get the perimeter of a square, don't forget I already told you that perimeter is sum of all sides. So you are saying L plus L plus L plus L, and that is giving us 4L because perimeter is sum of all sides. So the perimeter of a square is 4L and the area of a square is L square. It's just as simple as that. Now moving forward, for us to be able to get a triangle, okay, I didn't mention triangle in the previous video, in the previous plane shape that I drew. Now the triangle, to get the area of this triangle is half base times height, meaning this is the base and this is the height. So half base times height is the area of the triangle, and the perimeter of the triangle, I already told you that it is sum of all sides. If this is A, this is B, this is C, then the perimeter of the triangle will be A plus B plus C. That's the perimeter of the triangle. It's going to be A plus B plus C. And that settles the mensuration formula for this triangle. Now, the next thing is a circle. A circle. Now, when you talk about circle is in this manner, and it does not have the general things like the other plane shapes. Now, circle has this half of the circle, this line is called diameter, half of diameter is called radius. Now, when you talk about the area where the circle is covering, it's tag pi r square. The formula for area of a circle is pi r square. Now, when you want to solve for perimeter of a triangle, of a circle, it is tag 2 pi r or pi d. Pi d because 2r equals to d. So 2 pi r or pi d because 2r equals d. Now, the perimeter of this circle is still the same thing as saying circumference of the circle. Now, when you talk about circumference of the circle, you are talking about how it's moved, the whole thing till it gets to the other spot. So circumference of the circle is talking about 2 pi r because this is talking about the pi r that speaks about from here down to this place and the pi r that speaks about from here down here. So that's the circumference of a circle, which is the same thing as the perimeter of a circle. So moving forward, the next thing is a parallelogram. A parallelogram. Now, a parallelogram is very similar to a rectangle, just like it's slant. Unlike rectangle that is just straightforward. So if I'm going to shift the board a little bit like this, you're going to see clearly what has been drawn. So that's what the perimeter looks like, a parallelogram looks like. Now, the area of the parallelogram is base times height. This base, which is here, multiplied by the height, gives us the area. Now, one thing that I need you to be at the back of your mind is that the perimeter is actually sum of all sides. So if this is A, B, C, D, then it's going to be A plus B plus C plus D. Now, the next thing is rhombus. Now, when you talk about rhombus is similar to a square because that all sides are equal, but it's a slant square. This is also having its area to be base times height. So the area of a rhombus is base times height. Now, the area of the rhombus is base times height, and the perimeter of the rhombus is now going to be, because all sides are equal of this, so it's going to be b plus b plus b plus b. That can give you 4b or 4l, just like the square. Moving forward, we've spoken about parallelogram, we've spoken about every other thing. It remains trapezium. Now, trapezium, when you consider trapezium, you're having something of this nature, and this is the height, this is a, this is b. Now, the area of trapezium is sum of the two parallel sides times height divided by 2. Sum of these two parallel sides times height divided by 2. That's the area of the trapezium. So if this two parallel side is a plus b, then we can have it as 1 over 2 a plus b times height. So the area of a trapezium is sum of the two parallel sides times height all over 2. And that gives us this. Now you already know that the perimeter of a trapezium, we label this CD, then we're going to be having perimeter to be a plus b plus c plus d, because perimeter is sum of all sides, sum of all sides, sum of all sides, sum of all sides. So that is that about trapezium. Now the last one, which we're going to be considering as a plane shape, is the sector. Is the sector of a circle. Now, the sector of a circle is actually not in the generic term of the plane shape, but is a part of the plane shape. This is how a sector looks like. Now, when we are looking for, this is the angle subtended by the sector. Now, if you're looking for the area of this sector, because of this angle that is actually a segment of the whole circle, because sum of angle in a circle is 360 degrees. So, but because this is just a segment of the total angle in a circle, what this means is that we're going to be having it to be a fraction of the total, which is theta over 360, that accounts to the space being covered by the sector, then times pi r square. And you remember the area of a circle is pi r square. So if we are looking for the area of a sector, it means we are considering a particular section of the angle of the circle. The circle is pi r square. If it is the circle, 360 over 360 will give you 1. 1 times pi r square will give you pi r square, meaning area of a circle. But for a sector, because we're having a segment of this, if this is 30, then this will be 30 pi r square. And that settles it. Now, moving ahead with this, it means if we're looking for the perimeter of this same sector, you know that I said perimeter is sum of all sides. So this is going to give you radius, right? So by the time you add this radius together, you have 2r plus, now the length from this end to this end will actually be a section of the circumference of a circle. Now you know that I have studied earlier that the circumference of this of a circle is 2 pi r, right? Now if the circumference of the circle is 2 pi r and we're having just some aspect of it, meaning theta over 360 times this, will give us the perimeter of the circle, because perimeter of the circle is sum of all sides. So we're having R plus R plus this circumference that was covered. And we know the circumference of a circle is 2 pi r, but because of the segment that was covered is not the whole, we're having the theta over 360 degree, and this gives us this answer. So thank you for listening and staying tuned to the end. I hope you understand each and every of this formula that has been shared with you, how they arrive at them. So it's not something you need to just cram, put in your head and bombard yourself, get confused. No, it does not worth it to get confused over formulas like this. Understand the basics. Even when you are not remembering, you apply the insight that has been shared, you'll be able to arrive at it even when you are in an examination hall. Thank you for staying tuned to the end. From Distilling Insight, we appreciate you for coming over and over again. I will say that you stay tuned for more and more elaborate on this explanation on things. And for application of each and everything that has been shared, such will be shared in the later part of the class. Thank you and bye-bye.